Okay, hi everyone. I'm going to look at week 4 of EPMATH234, just to run through the course notes. Now, we're going to start probability. We're going to talk about sets, and then we're going to talk a bit about Venn diagrams. And firstly, sets. What are sets? A set, it's quite a simple concept really. A set is just a list of elements. You could just say a list of items. And we call things sets. You could have a set of stamps, set of records, set of cutlery, I don't know. I've got a set of cats that live at my house. And I can say, well, what's the set of cats at my house? I do these curly brackets, and I've got Nathan's there, Trevor's there, Trevor, Missy, and Bertram. That's a set of cats that live at my house, okay? In fact, if I was doing a question on the cats that live at my house, this would be something more than just a set. We'll come to it later. It's a universal set. Because a universal set defines everything that's in whatever we're discussing. Okay? If we're discussing the cats that live in my house, this is a universal set. And I would say you. Okay, that's the universal set. Now if I wanted to say the set of them that are ginger in colour, well, the set that's ginger in colour is Nathan. He's the only one that's... I hate doing curly brackets. Let's fix that up before anyone sees it. There we go. There's only one element in this set G that I've defined as ginger cats, because Nathan's the only one that's ginger. Okay? If I had the set of young cats, then there would be Nathan, Missy, and Bertram. Okay? I've got 3 young cats and 1 old cat. So within the universal set, I can make all sorts of sets. I can call them whatever I want, but these are sets. There are 4 elements in the universal set, so the maximum set I can make here in my discussions is 4. The set of ginger cats had only 1 element in it, and the set of young cats had 3 elements in it. Okay, now obviously we'll do ones with more numbers in it, like I might say the set of multiples of 5. And I might go 5, 10, 15, 20. There's more models of 5, I could keep going, but I can define things as whatever I want. That could be set MF, it could be just set M, just to keep it easier and potentially cleaner. Okay, 5, 10, 15, 20, fine. Now, we've got a few different symbols. There's a symbol we need to know. This funny looking E thing just means is an element of. I think of it like an E element. I could write the statement that Nathan is an element of the universal set. Do you agree that Nathan is one of the elements in the universal set? Yeah, totally. I could also get more technical and write G is an element of the universal set. Well, G is Nathan. There's no difference between G and the element Nathan, because we defined G and Nathan are equal. So I can say G is an element of the universal set because Nathan is a member of the universal set. Y is an element of the universal set. Missy is an element of the universal set. Nathan is an element in the young cat set. So whereas we're trying to make it look awkward and uncomfortable, it's fairly logical things, I hope. Here I've already said that I can name sets by this. Now note if I'm counting it up, I counted up 4 cats and there they were. Say I was in a classroom and I was just in a room with a few people. There are a few Davids, a few Johns, and a Mary. Yeah, good, okay. Let's keep with the times. Well, there's Mary's now. There's Mary Ann in the course. I replied to an email before. Irrelevant. If I said I'm going to define my set as unique first names that are in my room, I'll just define my set as David, John, Mary. I wouldn't write David, 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 John, John, Mary, 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 Mary. I don't repeat the answers, okay? You just list each element once. It's like if I was doing numbers down here, see if I had a group of numbers that were 1, 2, 2, 3, 3, 3, we just write 1, 2, 3, okay? Because we don't, if 2 and 2 are exactly the same thing, I don't need to write it twice. There's no reason to write it twice, okay? We just want a set containing a list of each individual thing. Okay, sets do not care what order the elements are written in, so 1, 2, 3 and 3, 2, 1 are the same thing. If they're numerical, I'd write them in order, but I don't have to. But anyway, okay, so there's some basic rules. Let's keep going. An empty set. say someone said to me, look, I want you to write down the element of, the set of dogs at your house and define it as D. And I go, fine. D equals, and I go to list, and unfortunately, I'd love some dogs here. Cats wouldn't. The cats love the fact that it's an empty set. So I can draw two curly brackets. I could also just go, look, it's an empty set. There are no dogs here. There are no elements in that set. It's the same thing. So it doesn't matter which one you put. We just need to know some of this notation, and hopefully they both look like an empty set. One's an old-fashioned way of writing a zero where you put a line through it. Or I don't know if it's old-fashioned or just different countries do it, but I've seen it. The other is just brackets showing, no, this is empty. Okay, that's empty set. A subset. Well, a subset is, by the way, after we've defined these, we're going to use these. We're not just saying, look, here it is, now we're finished with this forever. We'll use it within some of the other probability bits. So a subset is this symbol here that I've already circled. And that defines a subset. So I might say that the set of ginger cats is a subset of the universal set. I can write that. Subset just means it's part of it. Okay? Here that said A is a subset of B. Well, given that A is 1, 2, 3 and B is 1, 2, 3, 4, 5, 6, yeah, A is part of B. A is a subset of B. So a subset is any part of the second set. Okay? Be it one element, be it all the elements, it's a subset of it. Universal set I've already described, but let's do it here. It's a universal set is a list of all the elements that can happen in this set, whatever we're talking about, whatever the question is, whatever the experiment is. If we're talking about a question where we're just tossing a coin, the universal set is heads, tails. There's no other options you can get, head or tail. If we're rolling a die, which is a singular of dice, it would be, the universal set would be 1, 2, 3, 4, 5, 6. On the previous page, my universal set for my cat experiment was Nathan, Trevor, Missy, and Bertram. Okay. Cardinality, once again. I'd never used this term before this course actually. Cardinality is just the number of elements in the set. Okay? So this set A here, set A had the elements 1, 2, 3. So if someone asked me what is n of A, they just asked me for the number of elements in the set, or the cardinality of A. What's the cardinality of A? 3, because there are 3 things in it. What's the cardinality of B? 6. What's the cardinality of my universal set of cats? 4. What's the cardinality of my G, my set of ginger cats? 1. Yep. Okay, that's talking about, what's that, days of the week? Cardinality of days of the week is 7. There are 7 unique days of the week. Monday might continue to happen, but we don't keep listing Monday. There are 7 unique days of the week. That's it. Now, set operations. Again, we'll get to use some of these things. Union and intersection. Now, union is like a big U, and intersection is going to be an upside down U. And logically, I think of the fact that it looks like U, I just think of that as union. And I just think of the other one, I know, well, what's the other one? I've got a union and an intersection, and I don't get them mixed up because U goes for union and the other must be intersection. Now, what do they mean? Union, I think of like forming a union when you get people together. If I had a set of A that was the numbers 1 and 2, and the set B was the numbers 3 and 4, and the set C that was the numbers 2 and 3. Alright, I've defined 3 sets. Just for trivia's sake, I'm going to go up here and say, well, what's the universal set? And the universal set would be, I don't repeat them all, a 1, a 2, a 3, and a 4, a 2 I've already got, a 3 I've already got. The universal set would be 1, 2, 3, 4. Like we said before, we don't repeat elements, we just say, well, what's here? There's a 1, a 2, a 3, and a 4. Now, look at this symbol here. I'm going to say, well, what's A union B equals? All union means is put them all together. Don't repeat them if they occur twice, but put them all together. What happens if I put 1, 2, 3, and 4 together? A and B? Well, I get 1, 2, 3, 4. That's A union B. What if I ask this different question? What's n of A union B? Well, that would just mean what's the cardinality of that set? As in how many things are in that set? How many things are in that set? 4. What if I said, what is A union C? Well, A union C is a combination of 1, 2 and 2, 3. I don't write 1, 2, 2, 3. I just write 1, 2, 3. That's A union C. 1, 2, 2, 3 is just a 1, 2, 3. The elements in A, U, C are 1, 2, 3. What's A union B union C? That's just, hopefully you're seeing it already. It's a 1, 2, a 3, a 4, and a 2 and a 3. I've already got the 2, I've already got the 3. You may as well ask me what the universal set is, because the universal set is everything that exists in this set. Now, 1, 2, 3, 4. Note that I'm not saying A union B union C must be the same as the universal set. I could have changed this question and said, no, the universal set is 1, 2, 3, 4, 5. I can do that. I just didn't define a set with 5 in it. That's okay. If at the start of this question I said, look, the universal set is 1, 2, 3, 4, 5. A is 1, 2, B is 3, 4, and C is 2, 3. Fine. A union B union C is still 1, 2, 3, 4. I could say, well, we need intersection. From that universal set, I could say, what is the set of numbers greater than 5? Let M be the set of numbers greater than 5. Well, what's M? What numbers are greater than 5? None of them. M's an empty set. If I was trying to find the set of numbers greater than 5 and said, let that be M, well, M is empty. So that's what union does. Union just combines things. I think I started saying before, it's like a union of members of different groups, different unions and all that. Well, just because you might be a member of this union and this union and this union, when you talk about the universal set, they're not going to write your name down 3 times. You are just a member of this overall thing. Okay, before we move on to intersection, we want to finish off that union section with the definition of all. Because what we just did, union is like or, okay? And intersection is like and. Let's check. Actually, I'll go back to the previous page. Before, when I said I've defined set A as this, B as this, and C as this, I could have said, give me a list of all elements that are in A or B. Well, if they can be A or B, it's 1, 2, 3, 4. Yep, A union B is everything that's in A or B. Now, what about if I said this one, A union C, it's 1, 2, 2, 3. Now, when I say are you in A or B, A or C, do I include 2? Does or include and? 1 is in A or C, 3 is in A or C, 2 is actually in A and C. And within this course, the answer is yes. And is part of all. It's like if someone said, say I've got someone that likes listening to Queen and they like listening to Thirsty Merc. And someone says, do you like Queen or Thirsty Merc? If, say, I'm the person, I like both of them, do I say yes? Actually, I like them both. Does all mean it's got to be one or the other? Or does all mean one or the other or both? And we're going with that definition of all that means one or the other or both. So when I say A or C, I say 1, 2, 2, 3. 1, 2, 3 is my answer. I don't care whether you're in both, or includes both, or includes and. So there'll be other examples of this later when we ask questions, but entirely through this course, or is going to be the inclusive or. So if we say, what's the probability of getting this or this, then and is part of the solution. If it's possible to get both of them, it's part of the solution. Okay, more on that later when we come to the or questions. Intersection, well, intersection is like and. It's the overlap. I always think of the intersection meaning the overlap. Here we've defined a set as 1, 2, 3, 4, 5, and another set as 1, 3, 5, 7, 9. You don't always have to label them with letters. You can just write down the whole set. It would have been easier if I'd defined A as set 1, 2, 3, 4, 5, and defined B as set 1, 3, 5, 7, 9. Then I ask the question A intersection B. That saves some writing. But needless to say, we just need to know here what intersection means, and it basically just means what's the overlap? Who's in both? What numbers are in both A and B? 1's in both, 2's not, 3's in both, 4's not, 5's in both. So 1, 3, and 5 are the answer to that question. Which elements are in both A and B? Only 1, 3, and 5 are in both A and B. Look at this next question. I've got 1, 2, 3, 4, 5, intersection with 7, 8, 9. There's no elements there that are in both, so it equal to the empty set. Okay? And that's where we say the two sets are disjoint. If there's no overlap between them, no elements in both, then they're disjoint. They're quite unrelated. Okay, and there's no elements at all in their intersection. Okay, so yes, I think of intersection as and or overlap. Complement's the next word, and complement just means the opposite of. Like if I said, here's my universal set again from the first page. My universal set was, it doesn't matter what order I put in, I should spell, was Bert, Missy, Trevor, and Nathan. If that's my universal set, alright, so everything's defined, and then I said, what did I say? I said my set of young cats was Bert, Missy, and Nathan. Then what is Y dash? It must be Trevor. It's the rest. It's the opposite. It's the non-youngs. Okay, sorry Trev. So the set of young cats is Bert, Missy, Nathan, and the complement of Y is everything else that's within the universal set that is not Y. I'll admit I'm not used to this notation. I've always used Y with a bar over it. They're the same thing. I'm just saying if you learnt the same way I did, where complement was actually a line over the top of it, I will accept it, but we've still got to know what it means because questions will have Y dash. I might try and put both. But anyway, sticking to how this course has been outlined before I got it, this is the way we're going to define complement. So here's an example. Universal set has been defined as 1, 2, 3, 4, 5, 6. If A is defined as 1, 3, 5, then the complement of A will be everything else in the universal set apart from 1, 3, 5. Yep, A dash is 2, 4, 6. Great. Now, a deck of playing cards. We're not promoting gambling. I do promote playing cards. It's been many years, but anyway. Now, a deck of playing cards, we are going to have card questions. Now, within the course, well, I can't, this video might get used over years, so just refer to ask me whether we're going to have card questions in the exam. Last year we didn't, but I hope that this year we will. So I'm not going to say anything about whether it'll be in the exam or not, but it is in the course. Check with me if it's going to be examined or not. But yes, we're going to use a deck of cards. Now, if you know cards, great, okay, you don't need rules or games or anything, but here's the simplified version. What we need you to know, and I'll tell you now that if we have decided to put in exams, we'll put this on your sheet you get. Hopefully you're watching this in the future when I've finally gotten permission for everyone to use resource sheets, cheat sheets, memory aids, we write yourself. But if we're living right now, then we're still not got that permission yet. So I've just written a simplified version. As long as you know this is what a deck of cards is. Hearts, diamonds, clubs and spades. The red ones are hearts and diamonds, and the black ones are clubs and spades. And there's no one card. Some people call ace a one, depends what game you're playing. But in this, there's no one card. There isn't a one card. It goes from 2 to 10, jack, queen, king, ace. Why are we doing this? Because these playing cards are a really nice way to just come up with something semi-universal that most people know, or it's at least easy to find out about, to ask sort of intersection and union questions. You'll see that the questions are really good. Instead of coming up with a new scenario every time, we can just quote playing cards and know the layout. Otherwise, it's fairly laborious. So, let's look at a few facts. So for a question involving a deck of playing cards, a universal set is all playing cards. So the universal set would be putting curly brackets around and listing 2 of hearts, 3 of hearts, 4 of hearts, 5 of hearts, 6 of hearts, blah, 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 all the way up until ace of spades. Okay? So that would be me listing all cards. The quicker way to do it, what I've done here, is the cardinality. In other words, the number of elements in the universal set is 52. Well, that's true, because there's 4 what we call suits: hearts, clubs, diamonds, spades. I said that in the wrong order: hearts, diamonds, clubs, spades. Sorry, the order doesn't matter, I just should match it with what's on the screen. And there are 13 cards along this way. Okay? So there are 4 suits, There are 13 cards in each suit, and 4 13s is 52. Okay, there's 52 elements in this universal set of playing cards. For anyone that's played cards and knows there's sometimes a joker in there, ignore it. We're not doing jokers here. There's some arguments that occur about picture cards, about what are picture cards and what aren't picture cards. Let's just define it and move on. You can see I've had this argument before. I've defined numbered cards as cards with numbers on it. You know, it's pretty out there, but that's what I've done. So the cards numbered 2 to 10 are numbered cards. I've gone even more out there and defined picture cards as ones with pictures on them. So, you know, agree or disagree, that's what we're locking in. And then there's just the aces, okay? They're not pictures, sort of, don't go there. There's not pictures of some king or queen or jack or some person on them. Not a big picture on aces. So there's actually only 12 picture cards by the way we're going to define it. Okay, and here's my little simplified version. Okay, there are many subsets within this. You know, like there's spades, clubs, diamonds, hearts, black cards, red cards, jacks, queens, sixes. So it lends itself really well to probability questions, which I really just want to get the teeth into. Example, find the union of all spades and clubs. Let's go back to our picture. So say spades and clubs. Say we've already defined spades as this. Spades equals curly bracket or the spades, and clubs equals curly brackets or the clubs. The universal set of spades union clubs. Sorry, straight the word universal there. I don't know why I said universal. The set of spades union clubs will be, I'm not going to write them all out, all spades and clubs. Yep, that's spades union clubs. What about spade intersection clubs? How many elements are both spades and clubs? Nothing's a spade and a club, so that's a null set. Okay, those two are disjoint sets. Spades and clubs are two different things. When I union them, I just write all of them. When I intersect them, I get nothing. Okay, so spades union clubs, here I've written all black cards. Well, that's true. All spades and all clubs is all black cards. Then what about the intersection of hearts and the aces? Hearts and aces equals eights of hearts. Hearts intersect aces. Let's look at that. Hearts intersection. Hearts intersect with aces. Hearts is all of these. Aces, where'd it go? Hearts is all of these. Aces all of these. What's the intersection? What's the only card that's in both? There's only one unit in this. The ace of hearts is the intersection. It's the only card that is both a heart and an ace. Here's like or. If I said, what's a probability, I know we're not there yet, but I just want to use the word or. What's the probability of taking out a card at random from this pack of cards and getting a heart or an ace? In the future, you don't have to know this yet, but I know there's 52 items that I could pick from, and one card is a heart or an ace. And again, notice I'm saying or includes and. It's okay to be a heart and an ace. Okay? So if I say, is the ace of hearts a heart or an ace? Yes, it is. Actually happens to be both. I don't care whether it's that and that or that or that. But yes, it's heart or an ace. And another one that's defined there, intersection of the hearts and the clubs. We did something similar with spades and clubs. There's no overlap between hearts and clubs. Okay, again, there's going to be more of these questions coming up, and I'll also grab some out of the questions at the back just to make sure we're good. But we need to introduce Venn diagrams. Now, I like Venn diagrams. Irrelevant, but I do. Let's start building up. Here, let's look at this one that's already been built up. I've done lots of words there to say I build it up, but let's just look at a Venn diagram that's been built. What does it tell us? So I'm going backwards instead of forwards the way this happened. Well, what is in the set A? 1, 2 and 3 are in the set A. Looks like 3 is also in B, but is 3 in A? Just look at the circle A. I don't care about that line. Is 3 in the set A? Yeah, it is. A contains the elements 1, 2, 3. There's the first big mistake people make. They say A is 1 and 2. No, 3 is in there. Just because 3 is a member of B doesn't mean it can't also be a member of A. What's in the A circle? 1, 2, 3. By the same logic, what's in the B circle? 3, 4, 5. Now, what's in, I might ask, what's A union B? You'll say, well, that's everything union. Wow, that's terrible. That's in the union of A and B. What's in A and B? 1, 2, 3, and 3, 4, 5. Well, I'm not going to write 3 twice. I'm just going to say the elements 1, 2, 3, 4, 5 are in the union of A union B. And there they are. A union B is like me drawing a border around all of it and saying what's everything in the group of A and B. Yep. Stop scribbling right there. Now, what if I said what's A intersection B? What's in the intersection between A and B? There's only one number, and that's 3. The number 3 is there. And notice we've also got the number 6 isn't part of A and it isn't part of B. It must be part of the universal set. The universal set is everything defined within this rectangle. The rectangle around a Venn diagram is the universal set. It's everything we're discussing. So it's 1, 2, 3, 4, 5, 6. You'll also see some textbooks that write a U out here. You don't need to. That's just further defining that U is everything within the rectangle. So all this question is telling me is, what's every number that's within this question? 1, 2, 3, 4, 5, 6. Check. A is 1, 2, 3, and B is 3, 4, 5. That's a Venn diagram. Okay, let's move with it. So when I talk about A union B, remember I drew that little thing around saying A union B is everything within both. Yeah, that's what union means. It includes it's that, or the and bit. Yep. Intersection was only what's in the middle that intersects. The complement of A. Let's go back to the previous page and say, well, what was the complement of A? A dash. Well, if A is 1, 2, 3, and the universal set is 1, 2, 3, 4, 5, 6, then A dash must have been the elements 4, 5, and 6. Let's look at the picture. A dash is everything that's not in that circle, which is 4, 5, 6. Yep. Okay. Example, shade a region on a Venn diagram corresponding to A complement intersection with B. Now these, okay, I was going to say these are fun. Fun can mean different things to different people. So let's just look at it. I'm going to build it up first. Firstly would be defined as this is A and this is B. And then comes a question, shade the region on a Venn diagram corresponding to the intersection between not A and B. Firstly, let's look at what not A looks like. What does A dash look like? A dash looks like everything that's not in A. That's what A dash looks like. What does B look like? B looks like everything that's in B. So A dash is everything not in A, B dash is everything that is in B, and the question is asking me, what's the intersection? What bit is shaded twice? Now, see, here is, alright, A and B. So everything outside of the A circle and everything inside the B circle, what got shaded twice? What's got diagonals going that way and that way? This. And let's check. Oh, it's so nice I've got notes that are pre-written that are pretty. Would you agree? The shaded area is everything that's outside of A and inside of B. Ignore this other hatching, that was just my working out. My final answer is this. Is this area here outside of A? You bet it is. Is it inside of B? You bet it is. It satisfies both. That is the region that is both outside of A, check, and inside of B, check. Why wasn't this part of it? Because it's not outside of A. Why isn't this part of it? Because it's not inside of B. Why isn't this part of it? It's not outside of A, and it's not inside of B. No, it's just that moon-shaped crescent. Now, on Venn diagrams, can also show disjoint sets. We said disjoint sets are when they had no overlap. Alright, there's no overlap. We're not going to do questions on that. Our question's always going to have this overlap thing, even if you put nothing in there. We're going to draw them like this. This is our standard Venn diagram right here. But that can be done. And also subsets. We're not going to do exercises like this. But yeah, the elements of A can all be within the elements of B. Okay. So an example. Here's our stock standard good old example of questions we'll do quite a bit of. In a class of 35 students, alright, 35 total. Just going to write here. The 22 have submitted both of the assignments. 22 have submitted both assignments. 8 have submitted assignment 1. 3 have submitted assignment 2. How many students have submitted neither? Alright, bit of info. Like I said, our Venn diagram is always going to start the same. You can do 3-element Venn diagrams, we're not going to, okay? Now notice, there's always 2 circles, there's always 2 categories in the question. Here are the 2 categories I'm going to focus on, is A1 and A2. What students have, well, I'm not going to actually do this by individual students. Sometimes you could get listed individual student names. Sometimes you just know the number of students. So there's 2 ways you can write a Venn diagram. You can see here that here's some raw data. Now we're talking about something about, look, set A is ABC, D, set B is D, F, G, H. The universal set goes from A all the way through to M, and that's the way they panned out. But these 2 Venn diagrams are the same thing. There are 3 elements here, check, 1 in the overlap, check, 1, 2, 3, 4, check, 1, 2, 3, 4, 5. Okay, so we can do Venn diagrams either way, either listing all the elements, or listing, let's get technical, the cardinality. In other words, the number of elements that are in there. All we've got is a number. So the one thing that I can, like, 8 have done assignment 1. Now, why is there, oh, I missed a word. 8 have submitted assignment, only the first assignment, assignment 1 only, that matters. 3 have submitted only the second. That's what I get for reading it quickly. So 8 have submitted assignment 1 only. So there's 8 here. 3 have submitted assignment 2 only. What about here, the overlap, those that have submitted both? Yeah, that was given to us, that's 22. And what about those that submitted neither? Well, that's out here somewhere. How many submitted neither? Well, given that I know that all categories have got to add up to 35, and you can see there are actually only 4 unique categories in these Venn diagrams. In here, in the overlap, in here, or in here. There's only 4 numbers in a Venn diagram. I've got 3 of them and I'm missing 1. Okay, well, let's add them up. 8 plus 22 is 30, plus 3 is 33. All of these things only add up to 33. So there must be 2 more out here to make it add up to 35. There's my completed Venn diagram. Okay, let's check. 8 handed in assignment 1 only. Yep. 3 assignment 2 only. 22 have handed both in. And all these numbers add up to 35. Ripper. Okay, great Venn diagram. Now this one is going to have a twist. And I've written it out, but let's do it ourselves. Now notice the unique thing, which I admit I didn't write first time round. I was rushing. Because friends is nearly on. 22 students have submitted both their assignments. 8 students have submitted only the first assignment. As you can see, that only changed things. Let's look. This next one doesn't say only. There are 30 students in an English tube. Okay. I've got a habit of drawing a box and writing 30 there. Just to remind me that whatever numbers I put in the box, it's got to add up to 30. There's 2 groups. What are the 2 groups? We're talking about chemistry people, physics people, neithers. Maybe we'll talk about both. But definitely about chemistry and physics. Alright, C and P will do. You don't have to go to the side and let C equals chemistry and P equals physics. It's quite clear in this case that if you put a C and P, we know what we're talking about. So, now, the big trap. 19 study chemistry. If I was to just write 19 here, I've already made a big mistake. Because there might be some that study chemistry and physics. Okay, so I can't just say that 19 study only chemistry. This question, unlike the previous question, didn't say 19 study only chemistry. It said 19 study chemistry. So the truth might be 10 might do chemistry and 9 do physics as well. All 19 just chemistry means my total in the C circle must be 19. Okay, so it might be 10 and 9. It might be 3 and 16. I don't know. So I can't just put that 19 in there. By the same logic, 13 study physics. I don't know how many of them are in this part of the circle, how many of them are in this part of the circle. So I'm stumped at the moment. I can't do it yet. So this is our most complex type. What about 5 study neither? Can that go anywhere? That one's a winner. 5 study neither, I can lock that in. That means 5 aren't in the chemistry circle, aren't in the physics circle, definitely aren't in the overlap between chemistry and physics. They can't be there. 5's out there. Okay, well, now let's look at the total. So I know there's going to be a number in the C circle, in the P circle, 19 and 13 and 5. Let's add them up. The numbers we were given. 9, 12, 17. This is where you can think initially, hang on, well, this can't be right. It seems that way. How can there be only 30 students, but the numbers you've given me add up to 37? Clearly I've got an issue with 7 students, okay? Because I should only total 30, but they total 37. 7 students. What's that telling us? To me, it's instantly telling me 7 students must be in both. Let's see why. And this will always be the case. If there's an if you count them up and they add up to too much, however much more it is than the total it should have been, must be the overlap. Because when I counted 19 kids, say they're all in the room at one stage, so put up your hand if you like chemistry. I saw 19 hands. Put up your hands if you like or do physics. I saw 13 hands. There were actually 7 people that did both. So I've counted 7 people twice. So I shouldn't put the 7 people out here and the 7 people out here and count them again. I don't want to count people twice. So what I did initially was I counted those 7 people twice. That's why my total was 7 more than it should have been. Let's look at that. If there should have been 19 doing chemistry, and I know 7 do both, 19 minus 7 means there must be 12. There's 19 in the chemistry circle, check. There should be 13 in the physics circle. Well, there's 7 already here, plus 6 makes 13. There's 13 in the physics circle, 5 do neither. If I add it up, 12 and 7 is 19, plus 6 is 25, plus 5 is 30. Winner. Okay, it's a bit nasty, okay, but there are 2 main types we're going to get, okay. The one on the previous page was a bit of a gimme, because it said only, but there's 2 main types we're going to get. This type was, we got given neither, we got given our totals, we had to add them all up and find out how much more than the total they added to, and that allowed me to find the overlap. Okay. The other type, which I assume is the next one, but I'll just erase stuff here. Let's say the question told me, instead of 5 do neither, 5 do both. That's actually a bit of an easier question, because what would I have done then? I know I've changed a question, so this is no longer relevant. That's not this question anymore. I've changed stuff, okay? Let's say someone told me 19 do chem, 13 do physics, 5 do both, and they add up to 30. 5 do both means I can put the 5 straight in there. That's why I consider it a nicer question. Okay, then I'll say chemistry, well, if 5 do both, 5 take off the 19, that'll be 14. Physics, take the 5 off the 13, that'll be 8. And what do they add up to? 14 plus 5 is 19, plus 8 is 27. There must be 3 out here to make it up to 30. Again, totally different, but let's check things. Was there 19 in chemistry? True. 5 and 8. Was there 13 in physics? True. Was there 5 in both? True. And do they all add up to 30? 19, 27, 30? True. So 2 types. You'll either get given the number that goes into both, or the number that's neither. I assume the next one might be a neither. Well, we'll find out. It's a hearts one. Within a deck of playing cards, I define set H as all hearts and set P as all picture cards. Alright, H is all of this top row. The set of all picture cards, yoink, yoink, yoink. Okay, H and P. There are 13 hearts, true. H in H equals 13. There are 12 picture cards, 3 by 4, agreed. There are 3 cards which are both hearts and picture cards. Jack of hearts, Queen of hearts, King of hearts are within the picture cards and where they're within hearts, so yep, agreed. The cardinality, in other words, the number of elements in H intersection P is 3. Yep. So we can do a Venn diagram. I've already constructed it there, but let's look at the Venn diagram between H and P. Now, I'm not going to do it the same way here. I'm going to say hearts has got 13 in it. Picture cards has got 12 in it. Again, I'm not just going to write heart 13 and picture card 12 because there's potential overlap. What is the overlap between hearts, between all of these hearts and all of these picture cards? It's 3 cards. There are 3 in the overlap. Hence, for heart circle to contain 13, 3 plus 10 makes 13. For the picture card circle to add up to 12, we've got 3 there, so it better be 9 there. So let's look at what we've got so far. We've added up 10 plus 3 is 13 plus 9 is 22. We're talking about a set of cards. I know there's 52 cards in a set of cards. Standard set of playing cards the drawer is doing, which means there must be 30 cards out here that aren't hearts and aren't picture cards. Hence, that's how we got here. 10 in the H, 3 in the both, 9 in the P, well really 12 in the P and 13 in the H, you know, and 13 out there. Okay, so cards can go into Venn diagrams too. Now I've got exercises, and I want to nick one of them, okay, because we didn't do, okay, I see, I love these. I want to pick, what is the same? Okay, here's one where I said there were 2 main types. One where you've got to add all the numbers up and something seems like it's wrong, but that extra number was just the overlap. Well, sometimes you get given the overlap. Here, Anita and Bjorn are combining their Weet-Bix card collections. So when Anita and Bjorn, sorry, read the question, David, combine their Weet-Bix card collection, they have the full set of cards. Okay, so the universal set, between them they contain the full set of cards. Alright. Anita and Bjorn. Anita has 16 cards. Bjorn has 9 cards. But they have 5 cards the same. Instantly, 5 cards that Anita and Bjorn. Sorry, get your abba right. How many cards in a full set of Weet-Bix cards? Okay, well I know that 5, they had the overlap. It also said that between them, they own the full set of cards. There are no cards inside the full set of Weet-Bix cards that they don't have. It's subtle, but can you see how that's telling us there is naught out here? There are 0 cards within the universal set of Weet-Bix cards in this collection, whatever. Between them, they have the full set. There are no cards within the universal set that they don't have. So it didn't say put a naught out there, but it did. Is that speak good? Yeah, great. A is meant to contain 16 cards. Well, there's 5 there, so 11 plus 5 make the 16. B circle is meant to contain 9 cards. There's already 5 there, so put 4 there. So I'm going through my checklist now. Is the A circle containing 16? Yep. Is the B circle containing 9? Yep. Both is 5. Yep. I know that there were none that they didn't have. So what's the total number of cards in a universal set? It must be that plus that plus that. Okay, 11 plus 6, there is 20 cards. Therefore, there's 20 cards in this Weet-Bix set. Okay, so there's little subtle things. Words cause trouble, but please give them a shot. Remember, we're always available, and we're always really quick on the reply, I believe. Go discussion board first, because everyone's going to have similar questions, and we can read it, and we can all, and others can jump in and help in that. Discussion board's great. Okay, but give these a shot, and hassle us discussion board online tutes, and yeah. Is there anything else here? Oh, I'm going to do one more. I can't help myself. I just want to make sure that I haven't freaked anyone out, or if I have, I want to try and unfreak a little bit. This one, I'm going to do the harder of these two, which is this one. Okay, look, it's just yuck. It's just hieroglyphics. Let's make sense of it. It says draw Venn diagrams. Again, I promise, our Venn diagrams look like this. Now, it says n universal is 60. In other words, they total to 60. Inside this rectangle, whatever they are, they total to 60. Then it's talking about NA and NB. So NA, A contains 25, and B contains 17. I should write it in proper notation, but you know what I'm saying. The number of elements, the A circle contains 25, the B circle contains 17, and again, I can't just write them in yet. I don't know what the overlap is. The first question told me about an overlap. Great. N of A union B is 10. I would have written 10 there. The second question doesn't. The only other bit of... Oh, look at you, David. You've scribbled it out so you don't combine both questions. NA equals 35. NB equals 22. Fifthus. Okay. The only other bit of info I've got is N of A union B is 45. He's telling me, remember what N of A union B was? N of A union B was everything in both circles. Okay? The total number that's contained in both of these circles is 45. At the moment, I'm trying to squeeze a 35 and a 22 into there. What's 35 plus 22? 57. So I'm trying to squeeze 57 into a 45. What's the difference? 12. It's got to be that. Okay? Again, when you're trying to cram more in than you need to, then some people must have been counted twice. Who are those people that were counted twice? The overlap. So, if there's meant to be 35 in A, 35 minus 12, well, that's 23. Yep, there's 35 in A. There's meant to be 22 in B, 22 minus 12 is 10. So now there is 22 in B. Now, 23 plus 12, that's 35 plus 10 is 45. We've satisfied that condition. We've got 35, we've satisfied everything. Is there a number out here? Well, they're meant to total to 60. They don't at the moment, do they? They total to 45. As soon as it told us 45 there, we knew that had to be 15 out there. Now I've drawn a Venn diagram that satisfies everything it said. They're all up 60. There's 35 A's, there's 22 B's, and A union B is 45. Alright, hope that helps. Enjoy.